Today we will see how to find the derivative of the four trigonometric identities that are basically derived from these two trigonometric identities, and we will see that the derivative or the rate of change of the four identities will also be derived from the rate of change of the sin of x and the cos of x identity. So in the previous video we have shown that how to find the rate of change of sin of x by using the definition. So we can also find the rate of change of all of the trigonometric identities by using definition. There is not a big issue, but the thing is that we always want to make things easier for us. So first of all, we will see that how to find the derivative of secant of x by using the rate of change of sin of x and by using rate of change of cos of x. So let's see. We all know that secant of x can be written as 1 by cos of x because this is the reciprocal of cos of x. While talking about the rate of change of secant of x, what we have to do is just to figure out the rate of change of 1 over cos of x. So d by dx of secant of x is eventually d by dx of 1 by cos of x. And we know that cos of x, the rate of change of cos of x is equal to minus sin of x. So we will use quotient rule here first, that square of the function in the denominator, derivative of the function in the numerator, that is 1, so it comes at 0. The second function, that is the function in the denominator, as it is minus the derivative of the function that is in the denominator, and we know the rate of change of cos of x is minus sin of x, so this is positive sin of x and the first function as it is. After simplifying, we get sin of x over cos of x whole square. This will be written as sin of x over cos of x into 1 by cos of x. And sin of x over cos of x, we know that this is equal to tan of x, and 1 by cos of x is equal to secant of x. So this is the rate of change of secant x tan x into secant x. So by using the base rate of change of cos of x or the sin of x, we can figure out rate of change of any other of the four trigonometric identities, that is secant x, that is cosecant x, tan x, or cot of x. As we have seen here, that rate of change of secant of x is equal to tan x into secant x, and it will make work more easier than finding the rate of change of secant of x by using the definition. Heading toward another trigonometric identity, that is tan of x. So we know that we can write tan of x in the term of sin of x, and cos of x is sin x over cos of x. So while finding the rate of change of tan of x, we can use just the quotient rule here, that's d by dx of sin x over cos x, to figure out the derivative of tan x, because we know the rate of change of sin of x and we know the rate of change of cos of x. So this is really easy to find the rate of change of tan of x. We can also find the rate of change of cot of x, because we know that cot of x is the reciprocal of tan x, that is cot of x is equal to 1 by tan x. Or we can also write as it is equal to cos of x over sin x by finding the derivative of this by a quotient rule or by just taking the derivative. We can also use this thing and this thing. Two things are here to find the derivative of cot of x. And then moving toward the derivative of cosecant of x. So we know that cosecant of x, we know that cosecant of x is equal to 1 by sine of x. So by using the quotient rule here, we can find the rate of change of cosecant of x by using quotient rule, and by using this rate of change we can figure out the rate of change of the cosecant of x. So just to find the rate of change of sine of x and cos of x by using the definition, you can figure out the derivative of all of the trigonometric identities. But we can also find the derivative of all of the 6 trigonometric identities: sine of x, secant x, cot x, cos x, whatever it is. So by using the definition. So in the next video we will talk about some of the examples that we will solve to fully understand that how we can find the derivative of the functions containing trigonometric identities. So stay tuned. Goodbye.